Lesson 4-7, pages 555 and 556. After a football is kicked by a punter, it's subjected to gravity and follows a parabolic path. The height of one particular punt is shown in the graph. The first coordinate represents the horizontal distance, so why don't we highlight that? That looks important. From the punter, and the second coordinate represents the height of the ball above the ground. Both measurements are in feet. So it says about how high above the ground was the ball when it was kicked. So let's see what each one of these grids look like they stand for. So 5, 10, 15, 20, 25. So it looks like it's about 2.5 feet off the ground. Okay, and then the next question was how far away from where it was kicked did the ball land? So that's a horizontal distance, isn't it? How far away from where it was kicked did the ball land? So that looks like just a tad over 150. Let's see how these are numbered. So it looks like 150, 560, 575. So that looks like about 152. So it landed 152 feet away. All right, let's move this up just a bit. Then the next question they asked was how high did the punt go? So at the highest point, let's look at that. That we can pretty much tell, can't we? So 50, 55, 60. It looked like the punt went up. At the highest point, the punt was about 60 feet high. At the highest point, it was 60 feet high. All right, and then number 4, it says use a graph and some ingenuity to estimate the actual distance traveled. So we're not going to do this because they had suggestions like using a shoelace or a string and go along the path and go from there. And well, I just don't really know that that's what we want to do right now. Okay, so let's look at the next page. The next graph also shows the height of the ball on the y-axis, but this time the x-coordinates are the number of seconds since the ball was kicked. So again, let's highlight that. That looks important. So the height of the ball is on the y-axis, and the x-coordinates the number of seconds since the ball was kicked. Okay, it says the hang time of a punt is how long it is in the air before it returns to the ground. What is the hang time for this punt? So it looks like, if we're very careful, it looks like it was a little bit more than 3.23246. So a little over 3.6 seconds. Okay, after how many seconds was the ball 45 feet above the ground? Well, let's find 45 feet above the ground on our graph. So 25, 30, 35, 40, 45 is right there. Okay, then let's figure out what the x-coordinate was for that. Got one right here. And one right here. So it looks like it was 45 feet above the ground, about 0.9 seconds. And then it looks like maybe 2.7 seconds. So it was 45 feet above the ground. At about 9/10 of a second and 2 7/10 seconds. All right, so let's see what else they have for us. The equation of the parabola representing the ball's height is, and then here it is, which is a little bit different than what we're used to. This is a different form where f of x is the height in feet, and X is the number of seconds after it was kicked. It says find the exact height after the number of seconds you found in question 6. So we need to find F of 9/10. And we need to find F of 2 7/10. Okay, so when I put both of those in my calculator, and you can type this expression just as you see it in your calculator, it gives us 45 and 42 hundredths feet. Same thing on this next one. Okay, so if we wanted exactly, I guess a better approximation of the 45 feet, Desmos would have done that for us, wouldn't it? Okay, we could have just found where the point had the output value of 45 feet. All right, well, that's nice. Let's go ahead and go to, I'm going to pause this so you don't get sick. Well, we'll go to nowhere, but we're going to go to look at number 8. It says if you find the value f of 4 in this function, why does this result not apply to this particular punt? Well, let's go ahead and find that as they asked us. If we can look at that, the graph on page 556, I think you can tell why it makes, it has no application to our situation here. So when I put this into the function, I get negative 27.12, okay? So once the ball hits the ground, it doesn't apply anymore. It's not like the football is going to burrow down, okay? So negative feet makes no sense. Because the ball stops when it hits the ground. Okay, and then number 9, explain why the shape of the graph on the previous page does not tell you what the flight path of the ball looked like from the side view. Well, it was seconds, right? Not the horizontal distance. And I usually tell my students a story about when I went to TCU, we were extremely bad at football, so bad. And we had a guy who they gave an opportunity to punt the ball. Why not? Everybody else was bad at it. And so he punted the ball. The hang time was very, very long. Problem is he kicked the ball practically straight up in the air, which, as you know, maybe or maybe not for American football, would not be considered a good punt at all. So yes, the hang time was great. It didn't bounce. The initial bounce was not very far away from when he kicked it. The rest of the story is people were so surprised about how bad the punt was that once it hit the ground, it kept on bouncing forward, and it ended up being a pretty decent punt. But initially, what we were looking for is for that ball to go forward, on the initial bounce, but that's not what happened. Oh, this lesson is over, so you're going to need to do the 4-7 homework.